write-up that we're going to be following today, the tutorial. Um, I don't know if we have everyone but Robert. Let's see here.
No.
Oh, you will not be doing it. Hi. All right. Looks like we have everybody, right? 15. Yes, looks good.
Yeah.
Okay, cool. All right, so this tutorial will also be interactive, so just like yesterday's was. So make sure you fire up your PowerShell or terminal or whatever you have. So today we're just going to be going over. Let me send this link again to the file we'll be going over. Today we're just going to be going over some more Newton specifics. So how to transfer files to and from Newton, how to set up your environment on Newton, and actually how to use the resources on Newton, like the DPUs and stuff, to run your code. Um, so hopefully it'll be a little bit less of an info dump than yesterday. I know yesterday was a lot of info, but I hope today will go smoothly here, and Newton won't have any issues. So before we could dive into the Newton specific stuff, we're gonna be going over how to actually transfer files to Newton. And oh yeah, let me share my screen. Let's see. There we go. I gotta bring up the chat thing here. All right. So here we are. All right. So for transferring files from the command line, or for you can there's a lot of GUIs that are available, interfaces for transferring files. So some things are mentioned, like for Windows there's MOBA Xterm, which I recommend. It's a really nice program for being able to access SSH into Newton, but also it has a file explorer built in, so you can transfer files very easily. So that might be something good to look into, and it's pretty easy to set up. There's also another one for Windows called WinSCP, and there's a bunch of others for Mac and other operating systems and stuff. So if you want to take the time to set something like that up, that's it might make life a little bit easier with transferring files. But you can always rely on the command line to transfer files, which I'm going to go over today. Since we already have OpenSSH, OpenSSH will come with two protocols, SCP and Sftp for transferring files. The main difference is that SCP, it's not interactive, so you need to know like what files you want to transfer, or what files you want to get from Newton, like when you write out the command. While Sftp is an interactive program where you can browse Newton, and you can also browse your local computer at the same time, and get files and put files onto Newton as needed. Um, so I'm just going to go over just quickly how those commands we'll see in action. There's examples in the write up. Um, but oh yeah, so make sure everyone's connected to the UCF VPN so we can access Newton. So don't forget that. All right, so I just have just an example directory, and I have some files here, like some .py and an input file. Um, so I'm gonna upload this entire upload directory to Newton. So with SCP, we have the return of this R flag. As you can see here, it's already trying to fill in some stuff. The the tick R flag when you do SCP is for uploading directories. So SCP by default will only upload a file, so you need the tick R flag to tell it you want to upload a directory. And the basic syntax is to send a file, you want to do the tick R, and your first argument is going to be what you want to upload from your local computer. So I'm going to upload this upload directory, and from my local computer. So this is currently on my local computer, and then I want to upload it to Newton. So since we already have Newton set up in our SSH config, it's very easy. We can just type the name that we used to SSH to Newton colon. So this is meaning we're accessing the remote file system on Newton, and we want to upload it to the home directory. This that we have on Newton. So, and you can practice this with any file on your computer or any folder. It doesn't really matter what you're uploading right now. And so on Newton, by default, it's you start out in your home directly, like when you log in over SSH. So if I just do colon dot, that's just going to upload it to my home directory. And if I just click enter, you can see here. Oh, I don't know why it gave me that, but as you can see here, you'll see the little welcome message, and then you'll see that each of these files got uploaded. And now if I SSH into Newton and do ls, you can see here that upload directory is now here. If I do ls upload. See? Also, if you want to log out, I don't think I ever went over this, but if you want to log out from the terminal, you just type exit, press enter, and you'll log out. So now say I want to actually pull something from Newton to my computer, you just do the same thing but in reverse. So I want to SCP tick R because I'm going to grab a folder. I want to get something from Newton, and I want to get, let's just download that same upload directory I uploaded. So you can also, I don't know if it'll work for you guys, but for me, I can actually use tab to autocomplete directories that are on Newton because my thing will cache like what's on Newton. I don't know if that'll work for you, but it may or may not, depending. So I'm going to get something from Newton. So I'm going to get this upload directory, and then I just want to put it in the current directory I'm in. So I'm just going to use dot. And there you go. So we do ls, I just have a copy of that upload directory in here. So that's SCP. But sometimes you might not want to know like what's going on, and you may not remember what files you need, and the tab autocomplete's not working. So let's go over Sftp, which is going to be an interactive. So let's clear this out. So to use the command, it's just like SSH Newton, except we're going to SFTP to Newton. Press enter. And now you're going to get this SFTP prompt. Now, this isn't a normal bash prompt. Oh yeah, by the way, is everyone like good on running these commands? There's no issues, like no connection issues or anything?
Yes.
Everybody good? You
I'm
give me a
good.
little check mark. Okay, great. All right. Want to make sure I'm not losing anybody here. All right, so now we have an interactive session here. But again, this isn't a normal bash prompt, so I can't just like run like Python or something like this. Isn't technically you could, but it's not really it's meant for. So our main command. So you can actually type help, and you'll get a list of commands you can do here. Your main commands you're going to be doing is you're going to use put to put a local file on your local computer to Newton, and you're going to use get to get a file from Newton to your local computer. So there's put and get. And the interactive part comes from, you can use CD. So if I do ls, I can see I'm in my home directory with a bunch of stuff here on Newton. Now, what if so this is the remote command to do ls, and I can use cd and everything else. But what if I want to move around on my local computer? Because by default, when you run SFTP, it starts out on your local computer from where whatever folder you ran it from in the terminal. So if you any command, if you if you prefix it with an L, it'll run on your local computer. So let's see that in action. So I want to list out what's currently in my local directory I'm in right now. I could do LLS, so local ls. And as you can see here, I ran this command from the upload directory, so you can see all those files are still there. Depending on where you ran it from, if you're on Windows, you're probably in your users directory. So you'll see like your documents and things like that. And if you want a CD somewhere, so if I want to do LCD upload, and I do LLS, I just CD'd into like the upload folder that's in here, so with the same files. So that's how you move around on your local computer. So let's actually talk about getting and putting files. So let's do LLS, or let's do LS. So let me get, so I have this test here. Is there anything in it? Oh yeah, this is from our last time. All right, so let me get, I want to get script.sh, and I'm going to put it just whatever folder I'm in. There you go. There you got it. Fetching the file, gets the file. Good. So I don't remember if you need to tick R to get folders. We can try that out now. Actually, I want to get upload. Can I download? Yeah. So you probably need to tick R there. Yep. So if you need to get folders or directories, use tick R for recursive, and same thing for put. Sftp also supports being able to remove files. So you can remove files. You can do the pwd command, to get your, and then you can do lpd to get your local working directory. So you can see here. And you can also, I think that's really it. You can also make directories. So like if you're organizing files, you can do that right here. You can make different, you can make local directories, you can make remote directories, and upload and put files as needed. And if you need to run any command, you can, if you put exclamation point, or usually you'll hear people call it bang. If you put bang command, it will just execute a command like you were like logged into the shell. So like, or you can just do that, and then it should escape to go. Oh, just locked me out. So, oh, this is escape to the local shell. So this is you don't need to worry about these. That's for like running stuff in your local shell. All right. So that pretty much covers transferring files. There's a lot of documentation like on how to use these. So if you ever have issues using them or something, you can just look them up. There's a lot of resources online to really help you. They're not too bad once you get the hang of them. Or you can just use a GUI. So whatever works out. All right, was everybody able to transfer a file? At least, and then also get a file from Newton? Give me a little check mark. All right, awesome. All right, so we're gonna go ahead and exit then. And I'm just gonna do a regular shell to Newton. Whoa. I think I messed something up here. Oh, don't tell me Newton broke again. Yeah, that's the life. SSH messed up to Newton. Okay, give me a second. Let me see if I can. Okay. Oh, did I log in? Nope. All right. Sorry about that. Okay, that was weird. All right, so now I'm in Newton. So go ahead, so we can see that upload thing, and we're ready to go to the next part. So now let's talk about environments in Newton. So there's two aspects to maintaining our environment in Newton. The main aspects are going to be modules and our Anaconda environment. So everyone's familiar with Anaconda, right? I think you went over that with them, Robert.
Yeah.
Okay, cool. All right, so modules will be the new thing. So So on Newton, there's a lot of people running all different types of code that require different versions of different programs. So in order to make that, in order to be able to manage all of that for all the users, what Newton does is it has a system of modules. So if you need a certain version of a command, you load that module and you can use it for whatever purpose you have for this specific login shell. So if I load in modules right now and then I exit and SSH back into Newton, those modules won't be loaded anymore. So it's just for your current login shell. Um, so so this makes it a lot easier to, to, for at least on them, to manage all these environments. It makes it easy for us to get the exact versions of like Cuda we need, of Anaconda. Um, so if you want to, so first, all these are managed using the module command. So you can do module help, and it's going to give you a lot of stuff. But we're just going to go over just a few commands here. So the main command. So let's look at all the modules that are available to us. So if you run module avail um, and run it, you're going to get a lot of modules. So, and you can scroll down here using like the B and F, kind of like the man pages we learned about yesterday. The B and F hotkeys to jump pages, or use the arrow keys to scroll. And they're in alphabetical order here. So you can see we got programs for, so we have like Anaconda, we have Bazel, we got Maven, MATLAB in here. There's some Lua stuff. There's pretty much everything under the sun here. Some Cuda, which is what you guys are gonna be using. You're loading up your Cuda libraries for being able to run your code on the GPU. Yeah, so there's a lot of stuff here. So these are all the available modules you can load. You could press Q to quit this little list. I'm gonna go ahead and clear this out. So usually one that you're gonna be loading a lot is gonna be the Anaconda module, because right now we don't have Anaconda. So to load a module, we use the module load command. Very straightforward. And we're gonna load Anaconda. So the module for Anaconda is Anaconda / Anaconda 3. And you're gonna get this here. So, and if we want to list, the modules that we have currently loaded, we can do module list, and it'll list our currently loaded modules. So we have Anaconda. Let's just go ahead and test. We can load Cuda. So I'm gonna load Cuda 10.2. Oh, looks like I typed that out wrong. I think it's Cuda. Let's see, you have to do module avail and see what it is.
You forgot to put load, isn't it?
Oh, thank you. Yeah, that probably would have been helpful. There you go. So now module loaded. So you know list. There. So I see you have 2 modules loaded. All right, and that's really the basics. You just load the modules you need for the program versions you need, and you can use them. So that's pretty much the basics to that. So any questions on modules or anything? Nope. All right. All right, so now to the more juicy part of Anaconda. So Anaconda, you probably, if you're on Windows or something, you might have used the Anaconda like GUI interface, or I don't know what that. I haven't really used it. But from Newton, we're going to be using Anaconda from the command line. It's pretty straightforward. In the guide, in the little the right markdown file I've linked to the Anaconda starting tutorial from the command line, with just some basic things to do over Anaconda. So feel free to look over that when you have a chance. This has some more basic commands and stuff that not gonna have a chance to cover today. But so what's cool is that on Newton, if you do conda environment list, so env list, we can see that Newton comes with a bunch of environments, not these down here. It comes with a bunch of environments built in. So you can use these. They have some like different standard libraries installed. I find that I usually need libraries that aren't available in these, and you can't actually modify these environments, like you can't install something new to them. So I find it best just to create your own environment. So let's go ahead and do that now. Let's create just a simple machine learning environment that we'll probably use for most of our projects, and let's use the latest version of Python. So to create an environment, just very simple, conda create, use the tick n flag to specify the name. So I'm just going to name it machine learning ML. Um, and in with conda, you can specify what Python version we want. So we want Python version 3.8. And then you just press enter. Uh-oh. So you may get something like this, or you may get something that says aborted core dumped. So this is going to go into, this is in reference to this next section we're going to go over about getting resources. Basically what's happening here, Anaconda doesn't have enough memory and CPU resources to actually run. To fix this, we're going to go over this, what this command actually does in the next section, but you're going to use srun to run the command. So just put that whole command in front of srun like this. And Python equals 3.8, press enter. And I'll say this is queued. And then now it'll run here. It may take a hot second. So go ahead and everybody, let's create just a basic environment here. It's just that by default, when you're just using the shell on its own, you're not given a lot of resources to actually use. All right, so once you see this package plan and all of this, just press enter, and it'll start downloading everything and setting up your environment. So this will take like a minute or two. So just go ahead and let this run. If it looks like it's frozen, it's probably not. It just doesn't, it's just doing its thing. Any issues? Is everybody able to get it working with srun?
Mine wasn't working.
With srun?
Yeah, I got something completely different to come up on my screen.
You
Have
might
her
have.
share her screen, please, Brandon.
Yeah, this will be easier. Just want to share your screen.
Okay. This is what happened the first time I ran it.
It's because when you run the command, it needs to be Python equals 3.8. There needs to be no space. It's an equal sign between Python and 3.8.
Okay.
It's saying that it couldn't find the package 3.8 because it's not a package. Yeah. All right. I'm gonna share my screen back. Yep, and then just press enter. And
Okay.
it'll start up. Oh.
Thanks.
Yep. All right. So let's share this back. Okay. So yes, for some of you it may be quicker. Some of you it might be taking a hot minute. So as you can see here, mine's taking quite a bit actually. So verifying transaction. So we're just gonna have to wait to set it up. Pray to Newton actually run. All right, there we go. So just give me a check mark when you reach this and you see this to activate this environment and everything's done. Just go ahead and give me a check mark and we'll continue once everybody is has their environment ready to go. So the general format for when you're running, when you're creating environments, you want to type the package name equals whatever version you want. So if you want to install multiple packages, you can list them out by spaces. And if you want specific package versions, you do equals and then whatever version you want. So that's the general syntax for running the Anaconda. Um, but mostly you can you'll just create a very basic environment with just Python, and then you just install packages as you need them. That's usually how it'll go. So we'll go over next once everybody has their environment ready to go. All right. Is there any other errors or anything?
I just have a question. So when it
what's up?
says like the following packages will be downloaded,
Mm.
is it actually downloading that from online or is it taking it from the module?
So the module system is completely separate. The module is for loading specific program like binary versions like Cuda and things like that. Anaconda, these are all Python packages. So this is managed through Anaconda. And Anaconda does download these from Anaconda's repos that they have. So yeah,
Okay.
all these will get downloaded from Anaconda's repos, or if you already have them downloaded, it'll use local versions. But yeah, did I answer your question?
Yeah.
Okay, cool. All right, so we got one check mark. Awesome. All right, cool. All right, got another check mark. I think by now everybody should hopefully be finishing up with their environments. I tried getting this command to run faster. I was messing around with giving it more memory and stuff with srun, which we're gonna see in a second, but wasn't very successful. So sadly, just setting this stuff up on Newton just might end up just taking a while sometimes, which is just annoying, but is what it is. Once it's set up, usually you don't have to create environments over and over again. So. All right. All right, looks like we're almost there. Let's see. All right. Matthew, are you good? Still waiting?
Good.
All right. And Daniel, is your stuff set up? Daniel? All right. I think that's everybody. I think Daniel's okay. Just gonna hope so. Okay. So I'm going to go ahead and clear. All right. So I'm going to clear this out here. So now that we have our environment created, let's activate that environment. So by activating, what I mean is that we want to start using that environment with that Python version. So on the command line, you want to type source activate and then whatever the environment name is. So I called my environment ML. And then there you go. You'll know it's correct if you'll see this appear in front of your bash prompt. So home b Silva, which is my home directory, and then my environments and ML. So now we're in our environment. So if I do Python version, just to get the version of Python, see we're using 3.8.3, which is the version we installed. So we know it's working properly. So now that I've activated the environment and I'm inside the environment currently, I can go ahead and install more packages that I need. So for example, so I don't know if you guys use Python from the command line to install packages, but there's like the standard like Python. You can call it a package manager, but it kind of really isn't. Called pip to install packages. So you know pip install and then some package. However, with Anaconda, it's better to use Anaconda to install packages and use Anaconda versions because those are made to work with Anaconda. So usually we're running into less issues. And I included some examples in the write-up. So for example, if I wanted to install matplotlib, I can run this command here. So Ducana install, this is the channel. So there's like different channels or like different like repos you can install from Anaconda. Again, if you try to install stuff, you might get these memory errors or core dumped errors. So again, you just want to run this with srun in front. We're not going to cover installing these today because these might take a while. So, but those are just reference there. That's how you're just going to want to install packages. If you can't find a Anaconda version of a package, you can always just use pip to install something. And when you look it up, or when you look up how to install the package, you can use pip. But if you see a pip version, you can just Google search for an Anaconda version. Just search like Anaconda, whatever the package name is, and you should see something come up. And yeah, that's our environment. So our Anaconda environment set up. So now that we have our module, we know how to load modules, and we have our Anaconda environment set up to run our code. Now let's talk about actually running some code on Newton. So I'm gonna go ahead and clear out of this. So Newton, in order to run code on Newton, we got to learn about Slurm. So what is Slurm? Slurm stands for Simple Linux Utility for Resource Management. It basically allows the computer to distribute its available hardware resources to many users efficiently. So the reason why we use Newton uses Slurm is that when you're on your local computer, normally if you're running a program or something, your operating system will just use up as many resources that it needs on the computer automatically, or if you don't have enough resources, it'll max out, whatever you have available. But however, when you're on like a large server, like a server cluster like Newton, you don't want one user saying, yeah, I'm going to use 32 GPUs, here we go, and to run a program. And hog up all those resources. You want to be able to distribute those resources evenly among many, many, many different users. And I mentioned their server cluster. So the way Newton is set up, Newton is not just like one big computer with a bunch of stuff in it. Newton is actually a bunch of server what's called nodes that are linked together using I think it's over I don't know what protocol they actually use to link all the servers together, but all the servers are linked together to make it appear as like one big computer when you're actually using resources, but it's actually a bunch of separate computers together. And in the write-up, there's like a little diagram I'm showing. Right now, we're on the user node, so that's the EV user 1, and there's a bunch of compute nodes that actually have all the GPUs and CPUs and RAM and all those resources available. So and Slurm, so you can think of Slurm, and there's also some stats on Newton. Newton uses NVIDIA Tesla V100 GPUs, which are like $10,000 DPUs, 16 and 32 gigabyte VRAM, so very powerful. So yeah, there's a lot of stuff available for you to use. So if you're a little bit confused, you can think of Slurm more as like a printer queue. So like, you have a bunch of users like in the office, and they're all submitting jobs to get printed, and then they're put into a queue, and then they're printed in order as they come in. So Slurm kind of works the same way, although with much more complicated resources than just a simple printer. And I also want to mention too, before we move on, I know I'm just kind of talking at you. When I mention jobs, when I use the term jobs, I'm going to be mentioning the programs and what we submit to Slurm to actually get ran, the programs that we submit. So that's what I'm talking about, jobs. And so depending on like your user priority and stuff, you'll have to be put into a queue and wait for resources and things like that. So we'll talk about that. But that's just the very basics of Slurm. So again, Slurm is just a resource manager to distribute resources to users efficiently. All right, and there's so let's go over some commands for Newton and also for Slurm, just to kind of get some information and stuff about what's going on, and then we'll actually go into writing our first Slurm script to submit. So on Newton, there's some things available, and we're actually going to have to deactivate our environment because these won't work in our environment. So to deactivate your environment, do source deactivate. Just type that. You'll get this warning, but don't worry about it. So, and now we're back in our regular environment. So just to show you, if I do Python version, you can see I'm using 3.7. So if we want to get my, so in order for the view, when you're given through Slurm, you're given as a whole group, as the REU, you're given a max amount of GPU and CPU hours available to you per month. So if you want to view that, you can do my usage. Oh, okay. Yeah, it's just a Newton thing. I'm gonna have to relog in. So if you get that, you just have to exit and relog in. So I'm gonna do my usage. And as you can see here, I'm on a different account than you guys. I'm under Dr. Shah. But when you do my usage, you'll see the total amount of GPU and CPU hours used for your group. So yours will say usage account for CRCVREU. And you could see how much each user is used. So you guys will probably won't see anybody use anything, maybe like 0.1, because we ran the srun command. So the srun is a part of Slurm to actually allocate resources like some CPU and memory, so we can actually use Anaconda. But as you can see here, somebody's been using a lot of CPU and DPU hours here running stuff. But yeah, so you'll be able to manage, like you'd be able to see in real time, how much you're using for all your jobs. And these are Newton specific. Like these are programs that they have on Newton. Like this isn't like applicable to other systems. But so just to keep that in mind. You also have my quota. My quota just views your disk usage. So right now, this is how many disks you're using, disk or storage space. So right now I'm using about 400 gigabytes, and I have a 500 gigabyte quota. So yeah, that's just for viewing your stats. All right. So now let's get into the Slurm specific stuff. So this is for the Slurm commands. So before we go over actually submitting our job, there's a bunch of just informational commands and stuff that you're going to be using constantly as you go through your jobs. So we're just going to go over those quickly. It's just going to be a little bit of a command dump, but there's some interesting information here. So first, if we want to get, we can use sinfo to get a total like information about all of the nodes that are currently up. So as you can see here, we have a bunch of different nodes here. For the states, drain means offline. Mix means that some of the nodes are allocated, but not all. Idle means are all core, everything's completely available. So as you can see here, we have some nodes here. And then these partitions are like just like groupings, like they're just kind of just for knowing like what goes where. So you can see here, we can see all these nodes. We have nodes 1 to 6, 8 to 14, 16 to 20 that are mixed that are being used. 18 nodes there. So just to get some quick information. Now, here's the next big one. It's going to be the queue. So you can always view the Slurm queue to see like what jobs are currently running, what's pending, waiting to be ran, and things like that. And you're going to be using this a lot to see the status of your job. So when we run SQ, you're going to get a lot of stuff going on here. So as you can see here, there's a bunch of jobs being ran, and these are the names. Here are the users. As you can see, some of you guys were running Anaconda, so you can see the S run was running here. So your jobs were submitted here. So there's currently one job pending. So the PD means pending. All the R's mean that they're running right now. And then this is also like what nodes were allocated to run those. So you can see all these different nodes that are being used to run this. And the job ID. So the job ID is the ID of like whatever you submitted. And this is important because you can use the commands scancel to cancel a job. You can only cancel your own jobs, obviously. You can't cancel other people's jobs, but you can cancel your own jobs. So you can do scancel and then the job ID. So if this was my job, I could use this job ID and cancel the job. So it will just basically like control C, like stop it from running. And if you want to show more about a job, just like get like a huge info dump about information about a job, you can do S control, show, job, and then the job ID. So I just picked some random job ID. But you can see like the job name, job ID, who submitted it, priority, the stat, submit time, start time, how end time, what nodes are being used, the amount of CPUs, the amount of memory, how many GPUs, commands, so you can see all that. So yeah, so that's just managing your jobs. But now we know how to manage our jobs, but we need to know how to actually submit a job. So how do we submit jobs? Well, there's two different ways to submit jobs. We can use the srun command, which we saw before, which submits jobs interactively from the terminal. SRun is highly discouraged though for running your jobs like long term. It's good for some testing and doing some simple things, but not for running jobs for long periods of time. There's a few different things. Like one, when you run a job with SRun, sometimes the resources aren't released back for other people to use. They're like idle until you like exit out of the terminal. And when that happens, and now you're hogging up resources for other users because SRun is not properly releasing those resources back for other users. And actually, from the IT administration, they'll actually, if they see something running with srun for a long time, they'll actually cancel the job. Like they'll see that and they'll cancel your job. They don't like that. So just So instead of using srun, we're instead going to use a command called sbatch, and we're going to submit scripts to be ran. So instead of running it interactively, like in our terminal, we're going to be like, hey, here's a script file that details everything I need to run this program properly. I'm going to submit this script to Slurm, and Slurm's going to take that script and say, okay, I'm going to allocate whatever resources you need and run this script so you can so it runs your program. So let's take a look at a Slurm script. So I included this big example here that kind of goes over pretty much all the different options, how to use the modules to load your modules, how to use the Anaconda environments in your Slurm script. So if you can pull up the write-up on the GitHub that I have, and we're gonna copy this whole script here. Who remembers what text editor we can use to edit a text file?
Nano?
Nano, yes. We can use Nano. So let's go ahead and actually let's set up like a simple programming thing going on here. so we can actually submit a job that runs a program. So I'm gonna go ahead. So on your in your home directory, let's just make a directory called I'm just gonna call it first submission. This will be a good start. So I'm gonna nano. So I'm gonna run nano. We're gonna create a Python script file. So what's called nano. Let's call it main.py. And we're just gonna very simply, we'll just print something out. Hopefully with no syntax errors. Print a simple hello world. Yeah, let's just do that. We'll just keep it very simple just to show that the program runs. Maybe I'll print some other things. And we don't need to waste time with that. So we'll just write some very simple code, print hello world, just to print something out to the terminal. So remember to save, Control X, Y, enter. So now I have this program called main.py. And if I actually, to test it, I can just do Python main.py. Looks like I was able to write the code correctly, hopefully. So see, as you can see, it can run. But let's run this. Say this program is actually, all your code to run your model, and you need GPU resources and stuff. So how are we going to go about that? So let's go ahead and create our Slurm script. So when I say Slurm script, it's basically a shell script that we talked about yesterday, but it has some extra arguments in the script to tell Slurm to allocate whatever resources that you specify you need. So let's go ahead. This script I have here has comments on pretty much every line of code to tell you like what's going on and how it works. So this is a pretty good starter. So let's go ahead. I'm going to copy all this, my other monitor here, and we're going to nano. We're going to call it job.slurm. Press enter, and let's hopefully this pastes. Yay, paste. All right, cool. Although it has some like weird spacing. Well, not going to worry about that. Could fix the spaces another day. Everything's spaced out like too much. All right, was everyone good so far? Were they able to copy over this example script in?
Where did you get the example script from?
It's on the it's in the tutorial I linked. I just linked it again. In the
okay.
chat. Yeah. So if you
Thanks.
scroll down to the srun and slurm scripts section towards the bottom, you'll see it like this huge code block, and just copy everything in there. Just give me a check mark once you have the slurm script copied into nano here. The spacing is gonna trigger me. Must resist fixing it. All right, 3 so far. Okay, good. Just want to make sure we're on the same page. If you have any questions now's the time to ask about anything talked about so far. Okay. And some more check marks, great. Joe, are you good?
I'm having a bit of trouble pasting it, but I think I just got it.
Okay, great. I don't want to say your name wrong. Arushi? I get that right? Hopefully. Are you good? On Windows, you can just right click on PowerShell. Yeah. So if you're on PowerShell, you just hit the right click button to paste. Yeah. I did Control Shift V to paste mine, which if you're on Mac, you probably would need to do. Yeah. Good point. All right, is everybody good? Arushi, are you good? I'll take that as a yes. All right. All right. So let's break down this shell script. So this script, pretty much, as we said before, with a shell script will run a bunch of command line commands like that we use normally, like in the command line. We'll run them like one after another in a script, in an actual script file, kind of like how Python with the Python script file. Um, Except the one extra thing we have are these lines marked S batch. So you may think like, oh, is this a comment because it has the pound sign? But these are actually not comments when you do pound S batch. These are S batch arguments or Slurm arguments. So these Slurm arguments are going to tell Slurm what resources this program requires to use. So let's go ahead and break down what resources we want. So we're gonna break down every one of these commands has some comments. We'll break this down. So nodes define how many compute nodes we want to allocate. So on Newton, every compute node has 2 GPUs. So for example, if I want to allocate 4 GPUs, I would need to allocate 2 nodes because I need 2 nodes that have 2 GPUs each. So I need 2 to get 4 GPUs. So I need 2 nodes. Usually, you're probably not going to, anything you run, you're not going to, I mean, these are very big video cards, so 16 and 32 gigabyte. So most likely, you're never going to need more than 2 GPUs. So usually your nodes are going to stay 1. Now we're going to do number of CPU cores to allocate per task. And the task one is down here. So I'll go over in a second. But basically, this is the number of CPU cores you need. So in this case, I'm grabbing 4 cores. And then our next parameter for Slurm is how much memory we want. So there's 2 different ways you can define memory. You can just define like total memory, or you can define memory per CPU. So so in this case, I define memory per CPU. So for every CPU core, I want 8 gigabytes of memory. So in this case, if I have 4 CPU cores and 8 gigabytes of memory, this is in megabytes here. I'm gonna have 32 gigabytes of memory total to run this task. So again, nodes is how many physical like hardware nodes that you want. CPUs is how many CPUs you want. Memory per CPU is how much memory you want per CPU core listed here. The number of tasks, the reason why you do CPUs per task is that sometimes you may want to run tasks concurrently. So when you specify number of tasks, it'll actually run your program multiple times concurrently. Like, so say if I put n tasks equal 2, it would run 2 tasks. It would basically run this Slurm file, this whole entire script twice concurrently, and give you results. Usually you're not going to want that. Because you're running usually really large programs that require a lot of resources. So usually you'll just submit a different job if you want to submit multiple jobs for more resources. So usually you keep tasks at 1. But the option is there if you want to, if for whatever reason you need to do that. And then CPUs per task will actually define. So if I'm running 2 tasks, then I want 4 CPUs per task. So that'll be a total of 8 CPUs cores. And then this will then you'll be using 64 gigabytes of memory because this allocates per CPU core you use. So it all kind of works together with each other to make it easier when you're allocating resources. So now that we have our CPU and RAM, our last thing we're going to want is GPUs. We're going to need those. So in order to get GPUs, we use this gress flag. As you can see here, the flags are used 2 ticks instead of 1. That's just some programs will use 2 ticks for flags instead of 1. It's just a design of the program. So gress is for Slurm, gress just means like a generic resource, and the generic resource we want is a GPU. And how many GPUs do we want? We want 1. So this is to define how many GPUs we want. You could put 2 here to get 2 GPUs, and I have a little note about that. You increase GPU for 2 GPUs. You need to increase nodes by 1 if using more than 2 GPUs, and then I just basically explain everything I already did. So if I wanted to use 2 GPUs, I just go into my Slurm file, go ahead and change that to 2. Let's just allocate 1 for now. All right. So a few more options here. So this is all for allocating resources. So now this properly it will allocate all of the resources that we're gonna need. So now we just need to do some kind of just informational stuff like job name, like what's the name of the job and things like that. So there's also another thing called time. So by default, when you submit a job to Slurm, it only gives it, if you don't specify how long you want your job to run, it's only going to give you 10 minutes to run your job and then cancel after 10 minutes if your job is still running. So you got to make sure you put how much time you want to run your project, kind of like basically like a max time limit. So you have to specify. What I usually do is that I just put like 5 days. So right here I put 5 days. I just put a time that where my program will just complete before that time. You don't want to put too short of a time and end up your program exiting early because you just ran out of time. So just put like a large amount of time. I have it set here to 5 days. I usually don't have never had anything that ran longer than 5 days at one time. So usually just 2 or 3 days. So that's what the time argument here. And here, this is where we're going to actually start editing some stuff. So the job name here is what's going to show up in the queue. So when we did SQ and you saw the name of the job, this is what this parameter is. So let's go ahead and give a job name. So let's just call it test. I'm just going to call it test. You name it whatever you want. So we'll put the job name here, test. So the way SBatch works is you're thinking to yourself, okay, so if I'm going to submit a job and I'm not running it from the command line, how am I going to actually view output of my program? Well, what Slurm does is it actually uses it's going to have files, and it's going to append output to these files as the program runs. So instead of the program running and outputting it to standard out, it's going to redirect the output to output files. And the 2 output files you redirect to is standard error for errors and standard output is for output of your program. And here you want to put the name of your program. You don't have to use the same name as job name up here. You can put whatever you want. It's just, you just fill it in. So I'm just going to fill it in with the same name, but you don't have to use the same name by any means. This up here is just for Slurm. These here are more for like your sanity for managing, because you're going to be running a lot of jobs. You're going to have a lot of output files and stuff like that. So built into the Slurm script is going to be some organizational automation to like organize your files for you in a slightly sane manner. This is how like I organize my files. By no means do you guys all have to follow exactly what I do. You do whatever works best for you. But yeah, so this is just an example here. So I'm gonna have these are gonna be your output files and your error for both error and standard out. So this job name again. So we have another name file here, or a name parameter here. This is actually a variable that we're gonna use for the script. Right now, we just did all of our Slurm stuff. So all of this was just for Slurm. Now Slurm is completely configured. We allocated our resources. We named our job, gave it an amount of time to run, and told it where to save our output. Now the rest of it, we need to set up. Now the rest of this code is going to be actual, programs or stuff for running, running our code, running our program, and whatever, loading our modules, activating our Anaconda environment, things like that. So this job name is just the folder name for saving log files. How it works is that there's going to be this log directory. So what I do is that, so you don't have to exit out of Nano right here. But I'm just going to show you real quick. So how I do it, I have this folder in my home directory called jobber logs. So if I go here, I got a lot of jobs, and yes, they're called lit UAVs. So there's a bunch of different logs here that are all sorted for me. That this is what the script file will do for you. It's going to put all your job log files into a directory and then with the folder with the names for it. So when you go to, let me go back here. So so you can change the name of what you want to save it as. So this job name is going to be like what shows up in those log, like the folder name of those log files. So by no means you have to do it this way. I do it this way just for my sanity. Otherwise, you just have like just tons of like output files just like thrown everywhere, and it's like really hard to manage. So I just find that this just makes it a bit easier. So let's just call it. So we can name it something different. So I'm gonna call it first test. So when this job is finished completing, all my stuff is going to be created under the directory, the job logs directory and then inside that there will be a directory called first test. All right, everybody good following me so far? I want to make sure I'm not losing anybody. I mean, it's basically just a lot of the explanation for a script, so make sure I'm not losing anyone. All right. Good. Good. All right. So let's move on here. So the other thing I have to change here is that I find that so instead of doing a relative path, I usually for the log directory do an absolute path because I've had some issues in the past where it wasn't saving properly. So my log directory basically of where I want to save this, I want to do, you're going to want to put your username here. So whatever your username is. So my username is Silva. Yours is going to be the crcvreu.student and then a number. So make sure you put that exactly. Otherwise, it's not going to save properly. If you forgot it, you can exit out of Nano by doing a Control X, Y, and then press Enter. And then your user is just this here. So you can just copy this. Make sure you get it properly. Put it here. Would be nice to use relative paths, but I've had issues where I couldn't find the path file. I'll give everyone a second to copy that in. And in all of this, as you can see here, the money signs, these are actually accessing variable names. So this is accessing the variable name we created up here, the job name. And then this is a variable created by Slurm that specifies whatever the job ID is for this current job. So these are variables that are not created in the script, but created by Slurm that we can access. And the rest of this stuff is just like making the directories and stuff. So this is making a log directory. And then this is just exporting, this is just creating more variables. So debug logs is going to be stored in this, and benchmark logs are going to be stored in this. So, and they're both the same actually. So I just, or no, there's a Slurm job ID. Are they the same file? Yeah, I do use the same file. So you can change if you want different files for both of those. I use the same file. Just change whatever name you want. And by whatever name you want, you can just modify like this here. So I can just change this to debug. I'll change this to benchmark. So I'll use two different files for that. All right, environment setup. So that's all. This is all of our make everything nice logging. Make all of our logging very nice and easy. Now we're going to do environment setup. So remember modules, hopefully, because we're going to have to load them in. So we're going to load in Anaconda. We're going to load in Cuda. So I'm going to use the latest version of Cuda available, 10.2. And we're going to load in something called OpenMPI. So I always keep this loaded in. You don't have to. But what MPI, you're going to need MPI if you're using more than one node. And I'm going to go into this a little bit later about what MPI is. So don't worry about it right now. But you use this for when you have more than one node. But your main thing is you're going to be loading Cuda. That's like your main thing. And Anaconda. So again, in our shell script, we're basically running these commands like this is exactly how we ran them in terminal right here. We're just running those module load commands. So this is enter working directory. So the slurm submit directory is basically where you actually submitted the job. And that's actually a note that I have at the bottom, is that when you submit your job, you're going to want to submit the job. The script assumes you submit your job in the same directory of all your code. So like in that directory that had my main.py, that's where I want to submit the job. So Slurm knows where to go to actually access the code and files and stuff. So that's a very important that you submit your job in the same directory your code is in, so it can find it properly. Okay, so after this is like just a bunch of like this a huge amount of statistics. I just found that like I just needed like a lot of information to debug and do different things. So for example here, in the debug logs, it's gonna print out like Slurm working directory. So this is like where the directory it's in. As you can see here, we're actually using echo, but instead of just printing to the screen, we're actually redirecting it to the debugs log file, and we're actually redirecting and appending. So that's what's like a good thing for echo you can use to do something like this. So basically it's just writing to the debug log file. It's writing what the working directory is, a job ID, what nodes we're running on, how many processors do we have, things like that. Module debugging, it's going to print out like what modules are loaded to make sure our modules are actually being loaded properly, and not like just some issue and the modules aren't being loaded what I need. The MPI run location, which we'll talk about in a second. And also for benchmark logs, it's going to print out the time so you can see how much time your program took to run. So this is a bunch of like nice stuff that you're going to want just to look at when you're debugging. When you print all this stuff out, sometimes it makes it a lot easier to spot some weird errors or just something not right. So this is for your convenience. All of this is this extra. Really, all you need is just to actually run this, the bare basics, is the SBAT stuff, setting up your environment here, and then just running your program, which is going to be right here. So you don't need all this like debug logs and stuff, but it is there for your convenience to give you a head start in being able to do that, like debugging and stuff, because you'll definitely run into issues. So being able to debug those issues quickly is very important. All right, let's do this. So right down here, I have so there's a few different ways to split this up. What I do usually is that I define like what Python file to run, and like what arguments I need for my Python file, because you can specify arguments to the Python file if you use like something like argparse in your Python script. What I like to do is actually use separate variables. So when you scroll down here to actually running the job, I just do Python file args. So this line is really clean, and like my arguments and file are split up nice and neat, so it's a lot easier to see instead of like trying to like look at one huge long ass line of command to run. So the file that I'm going to want to run is my main.py file, and it doesn't have any arguments, so I'm just going to leave that blank. So when you remember when I talked about the activating the Anaconda environment, right? And you use source activate. So just as from my own personal experience with Newton, I found that half the time that the environment won't activate properly, and I tried emailing like the IT department and like really trying to debug it for a long time of why it wasn't working. Apparently other people it's just, yeah, it works fine, they can just activate it and everything's all good. But for me, I've always had issues. So your mileage may vary with it, but what I do just as a thing that always works is that instead of activating the environment and running Python, I instead use the absolute path to the Python file, the executable file for the program. to the interpreter, and which will which will by default will use whatever environment you set up. So what do I mean by that? So let's go ahead. We're going to do Control X, Y, and Enter. Let's save. And let's get back to the terminal here. And when I want to activate my environment, so first I got to make sure I load my Anaconda module. So Anaconda 3, make sure that's loaded. And now I want to do the source activate and activate my environment. So now I'm in ML. So there's another, so there's a program called Witch that will tell you the location of a program. So I would do Witch CD. The CD is actually a program that's stored in user bin CD. If I do Witch Python, you're gonna see where the Python is stored for your environment. And this is where it's stored for me here in the home directory. So as you can see here, is that you're not using the Python that's built into the system, you're using the Python that's built into your environment. And the way Python works is that if you use this, so instead of like having to activate my environment and stuff, so for example, I'm gonna do source deactivate just to show you. If I do source deactivate, and then I'm gonna run this here, so copy this whole thing. And I can run this and do version. And as you can see here, I'm actually running Python 3.8. But if I just do Python like this, I'm using the system's Python version 3.7. So this is what I mean by hard coding the path. And this always works. So I'm going to copy this. So go ahead and find out, activate your environment and see, do which Python inside your environment to see where that path is stored. And it gives you a relative path. So you can see it uses the little tilde for your home directory. So I'm going to replace the tilde with the home B Silva so we get an absolute path. All right. So is everybody able to use the witch and get the path to their Python? And check marks. Let's make sure everyone got this path here. I know there's a lot of little nuances with this, and I'm sorry for it, but this is just from my experience, and I've had issues. So I know I had to, especially at the REU last summer, I had to deal with these issues a lot and help people out. So hopefully this will give you a head start. You don't have to deal with all these stupid Newton issues. All right, so then let's nano the job.slurm script. Let's head back in here. And let's scroll all the way down, get back to where we were for Python. All right, so we don't have any arguments. So activating his Slurm script sometimes fails, so it's better. So this is the explanation of what we just did. And now we're going to export Python, and we're going to put in this path. And I'm going to hard code the path. So I'm going to do home B Silva instead of the tilde. So you can use what you used up here if you want to copy it. So you hard coded the path right here. So for you guys, you might not have to hard code paths, but again, it's better safe than sorry. And once you do it, you only need to do this when you change your environment. So home B Silva, my environment's ML bin Python. That's what we use for Python. Okay, now we have our resources allocated, log files formatted, Python program, the Python binary path set, and we also have whatever Python file we want to run. Let's run the job. Run what we want to do. So I have a multi-DPU if you're using more than this is for if you're using more than one node, and then single DPU, which we're just using one GPU here. So there's actually, I just noticed there's actually an error in this, which I'll fix in the script file on the markdown. But as you can see here, I put Python here when I need to do, forgot the little money sign to tell Python to use the Python variable I found here. So I don't know if I exported because I tested this script yesterday. So I just want to make sure maybe didn't have the error in mind, but we'll have to test this and make sure it runs, which we're gonna do, which we're gonna submit. But I don't want to give you a bad Slurm script file. So okay, so this fixed that. Let's fix that here and here. So I'll give everybody a second to do that. Okay, perfect. Okay. Once we're all done with that. So what's this NVIDIA SMI? So NVIDIA SMI command is a NVIDIA driver command that comes with the NVIDIA drivers to basically, it'll just print a bunch of information about what GPU is currently allocated. So that's really good to see what GPUs you get, whether you got the 32 or 60 or not the 16 gigabyte or 32 gigabyte GPUs. And then the time command basically will just measure how long your program took to run when you run time and then put whatever program you want. So again, I fixed the Python here and here. Here and here. So, and then it uses the file. So the file is what we defined up here. And then the args is what we defined right here. And then after that, once the program's done running, it'll print the ending time to the benchmark logs, and then it's going to clean up the output files. So the standard error and the standard out files, it's going to move those to the log directory because by default they're going to exist in whatever. So when you submit in your job, in the folder with your code, you'll actually see these two files, the out and the error, and then once the job is done, the script will automatically move them to the log directory for you, make it nice and neat. And whew, that was a lot, but that's just the basics of the script. You have your Slurm parameters to allocate your resources, some extra logging stuff, setting up
Brandon,
your
let
environment.
me hop in here real quick.
Yeah.
Have we submitted jobs yet? Because we got about 10 minutes left.
Yeah, we're just doing that right now.
Awesome. Okay.
Yeah. So now that we have everything ready to go, hopefully there's no errors. I'll just check back, make sure you fill in the names properly. You didn't make any mistakes. Make sure you had the correct username here. Even if there's an error, it'll still submit and it'll still do something. So that's fine if there's a mistake. It's not gonna be the end of the world. I called my file main.py. Make sure you have the right Python. And there you go. Easy, right? All right, so let's Control X, Y, enter. We're gonna save this job.slurm. And we're gonna wanna make it executable. So if you remember from yesterday, use chmod plus X for executable. And then you'll know it works when you do ls again and it appears green. I'll go over, I have some things about MPI in the markdown. I'm gonna skip over that since we're running close on time, about how that works. So again, I'm gonna just say this again to reiterate. Make sure when you run your job, your Slurm script is in the same directory as where your code is. So all my code. So say like the root of my project where all my code is stored, I called it first submission. I want to submit from this root. I want to be in this folder when I run the sbatch command to submit the job. So just to reiterate, it's very important. So now submit our job, everybody. Submit our first job. Sbatch job.slurm, whatever the slurm, we call it job.slurm. We're just gonna sbatch and we're gonna submit that job. And then I'll say submitted batch job. And if you do ls again, you'll see you got some output files, which might disappear very quickly, depending on what happens. So we'll do sq. So you can see here, looks like your job will complete very quickly because this is just like printing hello world. So let's see. You can do, yep. So actually there might have been an error with the Yeah, so there's an error with it didn't name these properly. So it looks like I messed up my name on one of them. So you can cat the error. So it didn't move the job logs properly, but that's an easy fix. But anyways, once you submit the job, so what you do is that you'll see these output files here. For you, if I might have messed up my name on something, for you, if you didn't mess up your name, those should be in the job log directory in your on your home directory. But if I use cat to print out the output, you can see I was given a 16 gigabyte GPU, and I printed hello world. So you'll see that the job submitted, and we're able to get that working. I'm gonna real quick just fix the name because I don't want to do that. Let's see, the test. Okay. Oh, I should probably read my own comments. For jobs for saving, it should be the same as job name defined in S batch. Okay. Sometimes I don't even read the documentation. All right. So that's why these files didn't move. But yeah, so it ran. And so if we go to the, did the job logs directory work? You may have gotten an error saying that the directory didn't exist. Did you guys get that error? If you print out the error file.
Yeah, I got it.
Okay. So I forgot to do this, so this is my fault. But if you go to your home directory, you're going to do make directory job logs. So it's like that. I already have the directory created, but do this in your home directory. Once you do this, you can just submit the job again. What's cool about it is that you can submit the job same time. You already have the Slurm file defined. So if you make errors or something, you can quickly edit it and just submit another job. So make the directory job logs. So sorry about that. You're gonna need to make that. That totally slipped my mind when I was doing that. I'm gonna update the script on the in the markdown to make so it's actually just to have the few errors fixed. So let's do the first submission again. Now that we have that fixed, let's run sbatch. Let's run the job.slurm again. 355, so I could see it there. And see if I got it wrong again. Which I may have done something, made it. Oh, nope. So as you can see here, they were there, and poof, they're gone. So that means the job completed. So now, if you have the jobs log directory created, if you go, you should have, if you ls job logs, you should see, as you can see here, there should be a folder called test, and then the job ID. So I'm going to cd the test. Whoops. I want to cd to job logs to test and this job. As you can see here, you're going to see your benchmark, your debug, your test, and your error. So we're going to cat the benchmark. So as you can see here, starting time, ending time, cat the debug. So my job ran on EVC7, ran on one node, one processors. Current working directory is this. Modules loaded. Bada bing, bada boom. Looks like modules loaded didn't print. Yeah, Newton sometimes does that. I've had that error before. Maybe cat
Hey guys,
error.
well, we got to end this meeting. Do you have any questions for Brandon that are going to take less than a minute? Okay, great. Well, you guys can always contact him. He's in the Slack, so he'll be available there.
Yeah.
But otherwise, Brandon, we appreciate you coming out, man. Thanks for a great presentation.
No problem. There's also one last thing you can read up in the managing and viewing Slurm output files on there, and I'll make the updates to the Slurm file on this in the write-up, so you'll have that available.
That's great.
Yeah.
Okay, well, thank you again, and we will talk to you soon. Guys,
right.
We're going to hop onto the next link. I can post that in the chat real quick here if you'd like.
Have fun.
Thank you.
Thanks.
Thank you.
Yeah.
Thanks.